So similarly for b12, it will get y12 because in that only it is there. So whatever the change happens, there only happens, because if something is not existent, intuition is something like simple. If something is not there, why it will impact other. Here simply b is independent and is dependent on b. For suppose it depends on many other, but one of the element is b. So whatever the change happens in y, it will be given to b12 only, because in y12 place only b12 has impacted. So the same independent dependent game, chain rule, and in forward propagation this helps to give this, and backward propagation whatever this helps to give the value y12. One of the parameter act as, because again x are there, k elements are also there, x elements, k elements are there, but these are also one of the elements because it is getting added over right here. This will be there, and x and k will be converted plus bias will be added, so it's helping there. So in forward propagation, so in backward propagation, as it is helping, as it is independent and this is dependent on this, so whatever change happens, it needs to give that change to this b also, because if you want to find derivative of loss with respect to bias 1 2, so here whatever changes happen, that needs to be given to here so that it will be learned. Because in backward propagation we will come from this side to this side. In forward propagation we will calculate b, or we have given the value of b, that will be used to find the y. But in backward propagation we will find derivative of loss with respect to y first, and that change nudge value, the nudge, like whatever the change, little change happened in y impacted the loss, so that thing has to be given to bias, so that nudge, whatever the nudge in bias value has happened, what will be the loss with respect to, what are the changes in the loss happens with respect to bias, so how much the loss is dependent on bias. So with that it tries to learn, because in gradient descent that only happens, right? If we will need to find new weight, we need to have old weight minus learning rate and dl by dw, right? Because if you want to plot a graph and for some epochs, we will get something like this. For suppose this is global minimum, so if we have this term as a like this negative positive and this is negative, so if you have positive, so for suppose this term is positive we have over here, and so w old minus something positive, so we are reducing it, so it will go something down, so we need to go here, right? Ultimately if we are here we need to go down, and the slope is negative, means negative of negative plus, so we are adding something to old, so it will go something over here, so this is a w. So that's how gradient descent works. So that's only the phenomena, chain rule, independent dependent game, the forward propagation happens over here, so and backward propagation happens over here. So as this value is giving change to this, so whatever the loss with respect to this happened, that needs to be given so that we can find loss with respect to this, because the energy in this value is how much it impacts the above value, because this is dependent on this is independent. So like so like that it happens. So again we can generalize y is equal to this thing, and dE by dy if we have given, we can just show that this is nothing but this is nothing, b for every bi it will be yi itself, as we have shown in the here capital letters, that capital letter notation is shown over here. Small letter notation nothing but b12 means y12 will get derivative of e with respect to derivative of b12 is nothing but derivative of e with respect to y1, derivative of y12. So like that it happens. So generalization also for big matrix, if we have for small matrices, whatever happens over here, like this previously which we have shown, that has been shown over here till here. For big matrices like that, like if we have something like this generalized manner, and again we have shown here, for that it's shown like this in a simpler way, but again here y1 is nothing but this thing entirely. Inside that we have y11, here if I want to show you, inside that we have y111, y12, y21, y22, all first one, and y2 is nothing but this thing, y112 we will be having. If we want to show y2 is nothing but y1, we have y11, y12, these are just elements, so that we will have same position we have to give suffixes or prefixes. So for everything it happens something like that only. So as I said earlier, we need to find derivative of error or loss with respect to features also, so that it can be useful for previous layers. So again, if you have given this thing with respect to y's, we have to find for input. So we have 3 by 3 input in this example. So for example, if we take with x11, we can just simply go for y11, y11 by x11, then y12, then y21 by x11. For every y's we can find, because it's a matrix of matrix or matrix of gradient. So as this is matrix of matrix or matrix of gradient, and for in this case we will get k11, because dy1, if we have dy1 equation here, y1 equation with respect to what we are doing, x11, we have this, but with respect to dy12 we don't have x11, because our matrices will be shifted over here. Like we have x in y12, we don't have x11 because this is the input image, right? For first we will over here, this is x11. For second we will go over here, and for third over here, and for fourth over here, if we will take valid convolution or cross correlation. So these values will be the output here in y11, y12, y21, y22. So in the first equation only, like dy1 by x11, so in y11 only we will have x11, and the derivative of that dy11 by x11 we get k11. So that is here, and for all it will be 0. So like that, if you will perform for x12, x13 with respect to x13, derivative of loss or error with respect to x12, x21, x22, x23, x31, 32, 33, we will get these results. So as you can see, there is no pattern, or we can't generalize in any way. Yeah, but we can't generalize that in a sigma notation like that we did in previously. We can't generalize something like this, or we can't generalize like this, which we did using some notations or something like this. We can't do, or we can't just show in items. We can't do like that, but we can show that using this cross correlation. See, it's nothing but we have this input, like as an input we have given this matrix, derivative of loss with respect to y. I can just simply show in capital letters d e by d y's, cross correlated with full operation with k filter matrix. We need not this, we need to rotate it by 180 degrees, so it will be this thing. And if we'll perform valid, like not valid, full cross correlation, we will get the output result as de by dx, what we are expecting. You can just check. Now if you want to show you, I will show you for one, k22 into de by dy1, right? And then we will be having d by dy1 to k21, that is nothing but this, right? k22, k1, k21, and 21, k12, 21, 22, k11. Are you getting it? So if we just perform like this, and this is actually in x22 case. x22 means in full operation, what we have to do means we need to take this matrix and we need to start from here, and in that case k11 by 12, so k11 by 11, k1 yeah, it's y11 k11, so y11 k11 will get, and then we'll take this and it will move to here, so we get y11 k12, y11 k12, and y12 k11, k12 k11. Then we need to take this over here and we will get y12 and k12, y12 k12, and we will come like this. We will get y11 k21, 21, and y21 with k11. And then as a and then if similar thing happens for this thing, what happens is like we will get this thing k22 y11, it will come like this and then like this. So whole thing what I have said, y22 k22 y11, k21 y12, k12 y21 k12, y21 k12, y22 k11. Then it happens over here, then it goes like this, it goes. So at last we'll get this, that nothing but k1 y22 k22 y22 k22. So it's nothing but this only. This is equal to this full cross correlation after rotating, that is nothing but convolution. So this is how from cross correlation convolution thing happens. So this, for this reason only at starting we have discussed about convolution, what is the relation between convolution and cross correlation. Yeah, mathematical operations, small difference here in full and rotation. So as we have discussed previously, what the little difference between those things is, that thing only we have discussed over here. This thing, convolution.